Well, welcome back, radical mathematicians. Here we go. So, yesterday we were playing around with simplifying and giving some equivalent expressions. So, this was just a quick little recap here from what we had discussed yesterday at finding, the square root of 24 is like saying 4 times 6 or 2 times 2 times 6, which gave you 2 square roots of 6 as the simplified form. And then we also did 9 times 6, which gave us 54, but that could also be 3 times 3 times 6, which gives you 3 on the outside and root of 6. I also gave you a couple of little quick reminders there about using 25 as the 5 on the outside, or 5 times those numbers on the inside. And so what we're going to do today, guys, is solidify this reasoning. Why did these numbers work like this? So what we learned were that we do have a list of perfect numbers, and these numbers make literally perfect squares. So if we do 1 times 1, we literally get 1. If we do 2 times 2, we actually get a square of 4. So when I do the square root of 4, it literally gives us a side length of 2. When I take the square root of 9, that's like taking 3 times 3, which means when I square root that, I get 3 back. If I take 16 square rooted, that means I take 4 times 4, which is just 4, the side length of my square. Same thing with the square root of 25, that'd be 5 times 5, which is literally 5. Continuing our pattern, the square root of 36 is 6, the square root of 49 is 7, and the square root of 64 would be 8 times 8, which is 8. 81 would be 9 times 9, which is 9. And the square root of 100 is literally 10 because that's 10 times 10. So these perfect square numbers, the key here, guys, is that they are square. It means that number times itself. And those are the only numbers that can break out of that radical symbol. So we have to use those to help us simplify. So we're going to give you 2 examples here to kind of explain this in 2 different methods. You guys get to pick which method that speaks to you, makes sense to you. So here's that first example on simplifying radicals. The first method is going to be on the left, and the second method will be on the right. So the first method is just figuring out what are my factors of 24. What times what gives me 24? So out of our multiples or factors of 24, these 2 numbers that multiply to make 24, are there any of them that are perfect squares? So 1 times 1 is a perfect square. So this guy would work. So we would put 1 on the outside and the 24 would stay on the inside. Now 2 and 12 won't work because 2 is not a perfect square number out of our list over here in blue. And same with 12, that is not one of our perfect squares. Same with 3 and 8, those do not appear on our list. The 1, the 4, the 9, the 16, the 25, the 36, and so on and so forth. But 4 does appear to be on our list as well. And remember, guys, this is like saying 2 times 2 times 6. Or you can think of it as 4 as that perfect square of a 2 by 2. Yeah, which means the 2 comes out and the 6 stays in. Okay, so the question is which one of these simplified answers is the most simplified? And I'm hoping you guys are going to tell me the second one is the most simplified. So we want to use, and why that is, guys, is because 1 times 24 doesn't do anything for us. It literally leaves us with what we originally started with, the square root of 24. So we're going to go with 2 square roots of 6 as our answer. Now, another way you could have handled this is by using your list of just the perfect square numbers. So what we're going to look at is 24 as a number underneath the root is smaller than 25, which means 25 is not going to help us. 36 is not, 49 is not, 64 is not, 81 and 100 is not. So what we're going to try is, can we divide 24 by this perfect square number of 16? So when we try doing 24 divided by 16, we end up getting a decimal. Yikes. So if we end up getting a decimal, guys, that means we cannot use that as our simplified process. So if I take 24 divided by 9, yikes, I get another decimal. That's not good. So if I get a decimal, it's not going to be helpful. But if I do take 24 divided by 4, you guys end up getting 6, which means 4 times 6 gives us the 24. So again, that means 4 is going to be our perfect square that we want to use. And 4, again, guys, comes from 2 times 2. Or some of you think of this as 2 times 2 times 6 as you're doing your process. And that literally is going to give us this simplified form of 2 comes outside of the square root and the 6 stays inside. So notice how we'll get exactly the same answer, but a little bit quicker. So it's your choice on how you want to go about this, guys. You can use your list of perfect squares based on the number underneath the radical, or you can just list me out every single multiplier starting with 1 or 2 and go from there. So let's do the last example here. It's a bigger number, square root of 128. So I'm going to do the first method one more time, where we pick 2 numbers to multiply by to get 128. All right, so since 128 is a really big number, we look for our perfect squares. So I see this 1, which would be a 1 by 1. I also see this number here, the 64. That would be an 8 by 8. I also see a perfect square here, which is a 2 by 2. And I also see a perfect square right here, which is a 4 by 4 to get 16. Ay caramba. All right, now listen, if I use any of these options, this is what we would end up with. So out of all of these multipliers or these factors, there's only one that is the most simplified. And notice it uses the largest perfect square that we had, which was 64 times 2, because 64 was 8 times 8. So that is the most simplified version. Now, if I wanted to do this using my perfect squares, 128 is more than 100. So we're going to try to divide 128 by all of our perfect squares. So I would take 128 divided by 100. That gives me a decimal. Can't use it. If I do 128 divided by 81, that gives me a decimal. I can't use it. If I take 128 divided by my perfect square 64, cha-ching-a-ling, that actually does give me a number back, and that gives you 2. Now you could keep going and do 128 divided by 49. That doesn't work. If I do 128 divided by 36, it doesn't work. And you can keep working your way back down and see that 16 would work, so would 4, so would 1. But 64 is the biggest that goes in nicely. So we will use 64 times 2, or we'll use 8 times 8 times 2. So 64 is 8 times 8. So the 8 comes out and the 2 stays in. And that, my dears, is how we simplify radicals. So it's your turn to practice. Please remember, you are doing both the front and the back side of your worksheet. Have fun.